Here we have a question on probabilities, and it's most likely going to involve drawing a tree diagram as well. So how we recognize this, obviously in an exam context, you won't know what it is without reading the question. So there are only green pens and blue pens in a box. There are 3 more blue pens than green pens in a box. There are more than 12 pens in a box. Simon is going to take at random 2 pens from the box. So this gives us an idea as to what the question's about. It's about probability. So you might need to skim read it like that first to understand it. So because we're picking out 2 random pens, and whenever they say things like that, where they're saying pick out 2 random pens, it's not that we're picking them out together. It's always take out one followed by another. Take out one first, then the next. It's always in that order, never 2 together. So if they say 2 like that, you kind of assume it's one after the other, unless they say pick 2 things out together in one go. So let's go back to the beginning and we'll go and do line by line maths here. There are only green pens and blue pens in a box, so that means we've only got 2 outcomes. We know probabilities like this, where we've got pens and different color things we can represent using a tree diagram. The outcomes, the 2 outcomes, is represented by the 2 branches in a probability tree. The outcomes are green and blue. The other thing which I do with these questions is always go and write down what we have, how many of each. So green, how many do we have? Blue, how many do we have? And then also the total, because this then enables us to write down what the probability is for each. So I've ticked the first sentence. I know there are green and blue pens in there. It goes on to say there are 3 more blue pens than green pens in the box. So there are 3 more blue pens than green pens. So if green is X, blue is going to be X plus 3. Because it doesn't tell us exact number, we have to use algebra here. And since we now know green and blue, we can find out that the total of that is 2x plus 3, because we've just simply added that up. Okay. So always start by doing this little box about what each of those things are. Now that we've got that, we can write down what is the probability. Now, probabilities are always written as a fraction. It is never a singular number. So a common mistake students will make here is they will just simply write down x. X is a number. It cannot be a probability. It's x out of the total, 2x plus 3. And likewise, blue is going to be x plus 3 all over 2x plus 3. So now that we've got green and blue written, that's the probability for the first pick. So in the first pick, this is the first pick. During that first pick, there are a total of 2x plus 3. The chance of getting a green is x out of that, and the chance of getting a blue is x plus 3 out of that. Now, since we're picking out 2 pens, we need to look at the second pick. So the second pick is going to be the second set of branches that we draw here. So here's the second pick. In the second pick, again, there's 2 outcomes because there's still a green and a blue. And likewise, we need to consider all the possible outcomes. So what happens if we pick a green first? That's along this route. And what happens if we pick a blue first? It will go along the other route. So let's consider this route here first. If we pick a green first of all, the total of the number of pens goes down by 1. So it'll be 2x plus 3, take away 1, which is 2x plus 2. Now, if we pick a green, then that means during the second pick, there is 1 fewer pen. It is 1 fewer green pen. So the green has gone down by 1, x minus 1. X minus 1 is not minus x. You cannot collect the like term, so that's again another common misconception. So we know that since we've picked up 1 in the first pick, all of the totals are going to be out of 2x plus 2. We can go and write that down for all of them. It will always be out of 2x plus 2 for the second pick because there's 1 less. Now, if we picked up a green, then during the second pick, the number of blues that we had at the beginning remains the same. So blue is still x plus 3. Now we're going to consider a different route. Suppose it wasn't green that we picked up first, but suppose it was blue that we picked up first. If we picked up blue first, then the blue pen goes down by 1. So then the blue, which we had x plus 3 at the beginning, will become x plus 3 take away 1, which is x plus 2. Now, if we picked up a blue, that means we haven't picked up a green. The greens remain intact. It should remain as it was originally, which is x. So now we've got our tree diagram complete for this whole scenario. We can look at all the different options, and we can then go and approach the question and answer what it's asking. So we've done this line here. Now this line here, there are more than 12 pens in the box. That's really important to understand. This means that the total must be more than 12. So I'll just make a note here. Total must be more than 12. I haven't used that information yet. I'm going to probably have to use it somewhere later down the line. Simon's going to take 2 random pens from the box. We've used that line to construct our tree diagram. It then goes on to say the probability that Simon will take 2 pens of the same color is 27/55. Now we need to understand what this is referring to. 2 pens of the same color. So that means we can look at, yep, absolutely. We can look at green, green, or we can look at blue, blue. So let's take a look at the options that we have. So we can go along green and then pick up another green. Now, when we want to pick up a green and another green, the key word I'm using there is green and green, and is associated with multiplication. The reason for that is because if we want something and something else to happen at the same time, we are essentially saying it's going to become more and more unlikely. For instance, I use the example of, let's say, winning the lottery. If we want to match 6 balls on a lottery, we want to get the first one, and we want to get the second one, and we want to get the next one. So each time it's becoming more and more unlikely. And to make probabilities more and more unlikely, what you do is you times the probabilities. And when you multiply probabilities, probabilities are less than 1, aren't they? Between 0 and 1. So when you times 2 numbers, which are between 0 and 1 together, the answer becomes even smaller. So it makes the chance even lower. So when we want something and something and something and something to happen, we are essentially saying we need to multiply the probabilities because it's harder and harder and harder for all of those things to happen at the same time. So that's why we multiply when it's the word and. So remember that, the reasons why we multiply. So then it will stick to your head what operation to do here. So we're going to do x over 2x plus 3, which is that probability, times with the x minus 1 over 2x plus 2. So that gives us the probability of getting a green and a green, but there's another option that we could look at, which is the blue and the blue option. And for the blue and the blue option, again, same thing here. We would do x plus 3 over 2x plus 3 times by x plus 2 over 2x plus 2. Now, the question says the probability that the 2 pens are of the same color. So being of the same color could have been green and green, or it could have been that. Now, the word or is associated with add. The reason for that is because when we say this could happen or this could happen, we are actually increasing our chances, increasing the likelihood of something happening. We're saying actually, no, we're not going to say this and that because that's reducing the likelihood. It could be that or that or that. We're increasing our chance of winning if we were talking about the lottery. Yeah. That would have been easy because if with a lottery, if we said match not all 6 numbers, match either this one or that one or that one, it's easier, isn't it? So then you would add the probabilities, because adding numbers between 0 and 1 increases that number, therefore increasing the likelihood for that to happen. So what do we do? Well, we take this answer. I'll write it in a more compact form. Multiplication we can denote like that, and 2x plus 3. I'll keep this in that form. And like here as well, we'll do any expanding or whatever is necessary later. But at this point, keep it in this compact form, in a factorized form. And because of that word or, we're saying that this probability added with that probability will increase. Yeah, we'll come on to the equal. That's essentially the probability of getting either a green, both greens or both blues. So probability of both green or both blue is equal to those two probabilities added together. Now, when we're adding any fraction, be it algebraic or just a numeric, the denominator must be the same. And as we can see here that the denominators on both of these are exactly the same. So when the denominators are the same, it's essentially looking at the numerators, which is x minus 1, plusing with x plus 3, x plus 2, all over, x minus 1, all over that common denominator, which we keep the same. And so that is the probability of getting either a green or a blue. Sinidin? Yes, the word or is associated with always adding. So now we can go and look at what else that sentence said. It said the probability that the two pens are the same color is actually 27 over 55. Now, since we found that the probability of the two same color is this, and we also know that it is 27 over 55, we have got the same probability written in two different ways. When certain things are written in two different ways, or you found the same thing in two different ways, it's the same thing. So if in maths, if we have two same things, we can use the word equal. So that's another skill that we use, which is forming equations, where when you have two things which are the same thing but written in different ways, you can put an equal in between them. So we go and write down x bracket all of that, and we can say all of that is actually equal to 27 over 55. Okay, so now we've got the equation. That was the kind of forming the equation. Now it comes to solving the equation, the next part. I'm still just focusing on that line. We're still doing line by line maths. I'm still just focusing on this line here. I haven't completed it because, yes, I've formed an equation, but when we have an equation, we should try and solve it if possible. And so we have fractions here, which we don't like. They're quite messy. We're going to get rid of the denominator by multiplying both sides by the denominator, and that will get rid of the fractions. So I'm going to go and do that here. So we've got x minus 1 plus x plus 3, x plus 2. I'm going to multiply both sides by 55 and 2x plus 3 and 2x plus 2. And I'm going to do that to both sides. I'm going to also multiply this side by 55 and 2x plus 3. Let me just bring that down a bit. So you can see what's happening. Write that in front of it here, times by 55 and 2x plus 3 and 2x plus 2. And remember, when we're timesing by that, that's the same as over 1. Okay, so not to multiply both numerator and denominator by that. What then happens? Well, as you can see here, we've got a common factor here, 2x plus 3, 2x plus 2 on the numerator and denominator, so that side simplifies. On the right hand side, we've got a common factor on the numerator 55 and denominator 55, so we can divide through by that common factor to simplify that down further. So what we get left with on the left hand side is all of this being multiplied by that 55. Okay, can you see that 55 there? So I'm going to put a 55 in front of all of this, equals, on the right hand side, I've got 27 times by all of that, 2x plus 3, I'll leave it like that. We're gonna go and look at the simplifying. So now I've got rid of my fractions by multiplying both sides by the denominator. Let's tidy this up a bit. We need to tidy this bracket up here, expand, simplify, and multiply everything by 55, and we've got something on the right hand side as well. So x squared minus x plus, when we multiply this out, it will get you x squared plus x plus 6. We'll keep that there. We'll simplify that later. And again, I'm going to keep the 27 here. When we've got 3 terms, multiply 2 of the terms and then times it by the other. Instead of multiplying everything by 27, I'm going to multiply the brackets first. And I'd encourage you to do the same thing here as well. So we'd end up with 4x squared plus 4x plus 5x plus 9x. Yeah, 2x times 2 is 4x, and 3 times 2x is 6x, sorry. So 6x plus 4x is 10x. Yeah. We made a mistake there. So 10x plus 3 times 2, which is 6. Okay. Now, I'm going to simplify each of the brackets before I times by the 55 and the 27. So x squared plus another x squared in there, 2x squared. And 5x minus x is plus 4x plus 6. All multiplied by 55 is equal to 27 lots of that. So I've got 4x squared plus 10x plus 6. Now, yes, we can divide both sides by 2 if 2 is a common factor in everything. So that's going along the principle of balancing. So let's go and divide both sides. We know 2 goes into both sides, both sides, so we can divide everything by 2. How you might kind of think about it like that as well, whenever we simplify something, find out the common factors first. So since 2 is a common factor, we can take 2 out as a factor as well from this bracket, and then this will become x squared plus 2x plus 3 equals, we'll take out 2 from that as well, and there. So then we have 2x squared plus 5x plus 3. So since 2, we can see the factors. We've got this as a factor, this as a factor, this as a factor, factor, factor. It's in a factorized form. And when things are in a factorized form, it's easy to simplify because if you have common factors, you divide through by the common factor. So we're going to divide through by the common factor 2 here. It tidies it up a bit. So essentially, you're left with 55x squared plus 1x plus 165 is equal to 54x squared plus 135x plus 81. We've got an equation which looks like a quadratic, but we need to solve, so make it equal to 0. Yeah, so 55x squared minus 54x squared, I'm going to get x squared. So I've subtracted the 54x squared from both sides, minus 25x, and then 165 take away 81. 165 take away 81 plus 84, which is equal to 0. We've got a quadratic equation here. This, if it's on a calculator paper, don't bother trying to factorize it. Just go ahead and try and solve it by using the quadratic formula. In terms of factorizing, I mean, we're looking for factors that multiply to give us 84, which is 21 and 4, and they also add up to give us 25, so it can be factorized. So I'll go down the route of factorizing in this case. We don't need to do AC method because there's no coefficient in front of x squared. Therefore, whatever multiplies to give us 84, which is 24 and 1, but we can also do minus 24 and minus 1 because we're trying to get to a minus 25. Therefore, we can go and say x minus 24 and x minus 1 equals 0. Good. From there, each factor multiplies to give us 0, so therefore one of the factors must be 0. So x minus 24 could be equal to 0, leading us to x equals 24, or x minus 1 could be equal to 0, leading us to x equals 1. We go back to our question. Since we've got 2 answers, surely we can't have 2 numbers for green. It's got to be either one or the other. There's a piece of information that says the total must be more than 12. If we went with x being 1, the total would not come to more than 12. We can check that because we'll have 2 lots of 1 plus 3, yeah, which is 5. So that is obviously wrong. So it has to be the other one, which is 2 lots of 24 plus 3. And 2 lots of 24 is 48 plus 3, which is 51. And that is definitely greater than 12. We've used the more than 12 part of the question. So x is equal to 24 is the correct one. I'll put a box through that and I'll cross out the other one, just using a single line to indicate that I have considered it, but I have chosen not to include it in my solution. We haven't answered the question. We've solved that all from doing line by line maths, and we were up to this stage here. The question, then next line goes on to say, work out the number of green pens in the box. Now green, as we've written down, is x. So let's make sure we answer. We have written down green is 24. So then we would put this in our answer box. or highlight that as that being the answer.